Hello everyone in CSC-134. The purpose of this video is to walk you through creating a program that uses 3 synchronized arrays to process a menu. This is similar to what I'm looking at right now for, as you can see, Project 10. Your Project 10 has you creating a pizza ordering program. Those of you that have taken Python may remember doing something similar a couple times in Python. We're doing something very similar in C++. So this program for Project 10 anyway required you to ask them what size pizza they wanted. They replied with a menu option A, B, C, or D, and then it responded with okay, you want a medium. They're $14.99 each, and then it asked them to key in how many they wanted. They keyed in 2 in this example, and it calculated their total. So rather than doing this with a bunch of if and else if, you can implement this with 3 synchronized arrays as long as you can search the first array. And this week we've already had a lecture on searching arrays, both using a linear search and a binary search. I would encourage you to watch that material before going any farther with this video. So let's make an example program that is similar to your Project 10, but not your Project 10, so you can see how I will implement this. So in Module 7, the lecture is right here, Menu Processing Demonstration using C++ arrays. And so what we're going to create in this video is a program that allows folks to place orders for wire. And if you've ever purchased wire, you know it's priced by the size of the wire, the thickness of the wire. A higher gauge wire is a thinner wire. It's actually reverse. The heavier wire is like the lower the number. So this program will present a menu to someone. Option 1 would be for 18 gauge wire. Option 2 would be for 14. Option 3 for 10 gauge. And option 4 for 8 gauge. So they're presented with this at the start of the program. They type in a 1, 2, or a 3, or a 4. In this example, they typed in a 2. It should figure out that if they typed a 2 in, that they want 14 gauge wire, and it is 39 cents a foot. So here they typed in 2. The program responds, that's 14 gauge at a cost of 39 cents per foot. It then asks them how many feet they need. They typed in 100. It multiplied the 39 cents a foot times 100 and came back with their total. So let's implement this with 3 arrays, and we can either use a binary search or a linear search. These are really short arrays, so it wouldn't make any much difference at all. So let's get started. I have this template starter here that basically just has some comments at the top, and it has a main function fleshed out for us, and that's all. So we'll need to add a bunch of stuff to this, And we can start by putting in today's date. Just so happens it's April. And program menu array demo.c++. Okay, so let's go ahead and get our includes right. I'm going to use the algorithm library functions to search these arrays. So they're a lot shorter and don't require any loops to search the arrays. So include algorithm. That's got our functions for searching arrays in it. Since we're doing some formatted output, I'm going to need the IOMan IP library. I'm going to need the string library. Okay, and I think that's it. We've already got include IOStream. We've already got using namespace. So let's go ahead and create a constant for the number of items. const constant int num items equals 4. That's how many menu items we would have. And we can go ahead in our main, we can create 3 arrays that will be synchronized. So we'll get started with that. Options will be our menu options, gauges for our wire sizes, and one final array that will have our cost per foot in it. Okay, so that's our comment. Let's go ahead and create our menu options. Now in this particular program, our menu options are integers because it's 1, 2, and 3. Your project 10, you would need to do something different because they're letters, not numbers. So here I am creating my array of menu options, and we'll go ahead and initialize it at runtime, or excuse me, at design time. So that's our array of menu options. And remember, if you were initializing a vector to do this, you would leave the equal sign out. All right. So we've taken care of our options 1, 2, and 3. Now we need to do our wire gauges. So those will probably be strings. Again, num items, just so we know how big that array is. And we'll initialize it. And it's going to be synced up. Let's see if we can make these all line up. It's always nicer when you can do that, just so folks can see what we're doing. So this is going to be 18 gauge. 18 gauge. Let's see if I can make that line up. I'll line it up on the commas if I can. Okay, there's our first menu option, just like we're doing synchronized dancing or something. Okay, next one is 14 gauge. And that'll be for 2, so I'm lining that up. These don't have to be lined up, folks. Just keep that in mind. I'm trying to make it where it's real plain that you can see what I'm doing with these synchronized arrays. That's my only purpose for lining it up, is just to make it hopefully easier to understand. So doing our 10 gauge, and that is option 3. So I lined it up. And our last one is 8 gauge wire. And that is option 4. So, okay. So you see how these 1 is synced up with that. 2, we're syncing off the position basically. Position 0, because things start counting at 0, or index of 0 would be 18 gauge. Index of 1 would be 14 gauge. You notice how I'm because we start counting at 0, these numbers are 1 off. So position 2, index of 2 would get us 10 gauge wire, and index of 3 would get us 8 gauge wire. So we've now created options, we've created gauges. We need to do this last array for cost per foot. We can make it double. So data type and cost foot. How's that? And we'll make it num items as well. So all these are, you see how all these are synced up, right? Trying to make it where it's very plain what's going on here. Okay. So let's go ahead and do our last one here. This is going to have our cost per foot in it. And we'll go ahead and initialize this at design time as well. Okay, so this first one's going to have 0.30 in it for 30 cents a foot. And that is synced up with that. And then our next one for 14 gauge wire. 14 gauge wire is 39 cents a foot. That's where I'm getting this stuff from. 39 cents a foot. So 0.39. Okay. Next one is how much is that? 51 cents a foot. So this one is 0.51. Okay, that matches up with those. And our 8 gauge wire, the most expensive thing here, is 79 cents a foot. 0.79 cents a foot. Okay, so you can see how while this stuff doesn't have to be all lined up, I did it so you can see what's happening. If we look up a 1, when somebody types a 1 in and we search this array of menu options and find the 1 at position 0, then we could say gauges, square bracket 0, and get to the 18 gauge and so on. The cost per foot would be cost per foot square bracket and the index for whatever we found. So hopefully you can see that we're going to be needing to search these arrays. So let me go ahead and put my semicolons on the end of those statements. Alright, let's declare our variables here. Int option chosen. We're going to have another int that's position where we found it. Another one for feet ordered. Okay. We'll have a string where we capture the cable gauge. and we'll have doubles for cable cost and total cost. Okay, so we've got that. Let's go ahead and start asking the person that's running the program for some stuff. Cout, what gauge wire would you like? So that's gonna prompt them, and we'll also do a cout, and let's see what the next line is supposed to say. This is what the next line says, so I'm going to copy it and paste it and save myself some typing. So I've already got my double quotes there. I can paste that in and put some double quotes on the end of it and do my end-L to make it go to a new line, and we've got that taken care of. Now let's enter our prompt. Cout, please enter 1, 2, 3, or 4. Notice we didn't go to a new line because we're going to do our CN next. CN. We're going to capture something into option chosen. Okay. So we're asking them, and they're going to key something in. Let's search that array. Now, we could do a binary search, or we could do a linear search. How about we go ahead and do a linear search? So we'll need to do our linear search, and we have got the code for that. If you recall, out here in this folder, right here, array not sorting, right here, searching arrays lecture. Okay, we'll just say we're going to do a linear search. Okay, so here is the algorithms library code right here. Now you remember we've already included the algorithms library. We do need a function template, function prototype, function prototype. So let's go ahead and put that up at the top of our program. I just copied that, and here's our program, and somewhere up top here, let's do it after the num items. We'll paste that in. Now right here where it says size, that's a constant for the array that we're going to be declaring. So, or not declaring, we've already declared down here. But you can see instead of size, we're using something called num items. So right here I'm going to change that to say num items. Okay, so that's the template, or not template, that's the prototype for our linear search function. So now we can go back and grab this and copy it to the clipboard and come back in here, and down below our main function here, you notice that's the end of the main function right there, and paste that in. So here's our linear search function, and you remember right here we had to change that where it has size. we want that to be the number of items. So I'm going to come down here and inside the square brackets, I'll paste that. And so I shouldn't have to change anything here. Shouldn't have to change anything because we're searching our menu options, which already contains ints. It already contains ints. So I'm searching that right here. Okay. And we've already got an int that we're searching with. So that's perfect. This should work great for what we're wanting to do. Now in your project 10, if you make your menu options characters, then you may want to declare this as a character, and of course you'd have to change this to char up here as well. But anyway, so we've got our linear search function out there now. So we can go back and work the rest of our program out. So here we've already got the option. Now we need to search for it. So we'll put a comment in here. Looks like we already had started a comment right here. Do a linear search of the, what's our array called? Menu options. Do a linear search of the menu options to find the position of the wire chosen. Okay, so this is where we're going to do our search. Position is going to hold that. We've already declared that variable up here, right there. So we've already declared it. We're wanting to find where that is. The name of our function is linear search. Okay, and our linear search function is going to need to know what the array is that we're searching. So we are going to pass an array of ints in here. Okay, so right here I'm going to put menu options. That's what we're searching. And we want it to come back. It's only going to take two things in. The first one is the array. The second one is what we're searching with. And we're searching with option chosen. Okay. So that's going to do our linear search right there. When this is run, it will find where whatever they typed in, 1, 2, 3, or 4, it's going to find wherever that was found. Let's say they typed a 3 in. This would come search the menu options with that 3 that they typed in. It would find it at position 2. Remember, this is 0, 1, 2. So our position would then have a number 2 in it. So at that point, we've got all we need to make the rest of this program work. So we do need to make sure that if it wasn't found, that we let somebody know. And so if option chosen was not found, then we can just exit the program. So here we'll have an if statement to handle that. If position is equal to a -1, that means we didn't find anything. We didn't find anything, so we're gonna just bail at this point. So we'll write a message, cout invalid option, program exiting, and we can do a indel on that. Okay, so we've got our search here. We're testing it out right here. So why don't we go ahead and build this and run it. Go ahead and save this as our menu array demo. Okay, so that's saved. Let's go ahead and build it. Looks like I've got a it's expecting what is it saying? Expected primary something in front of looks like I messed something up here. Let's see what I've got going on. Okay, I probably left a semicolon out, but let's see, constant, oh yeah, right there, I left the T out. Okay, so fixed our first error. Let's see what else we messed up here. Okay, I have a double cost per foot. Hopefully I didn't leave something out there. Probably the error here is above that line. Let's see. Double cost per foot, number of items. Okay, it's happy with everything up here. It's not happy right here. Int option chosen. Okay. Let's see if we can figure out what we messed up here. It says, oh, it finished successfully. Those are all just warnings about things that we didn't use. So we're good. Okay, let's try running it and see what happens here. Alright, so if we enter a 1, 2, 3, or 4, it should find it, and it should just run to the end and not do anything. So let's try that. Okay, and you can see it did. So now let's put an invalid option in. So I'm going to put a 7 in. And you see it said invalid option and program exiting. So we're good at this point, although I didn't like the way my prompt looked. Right here, I think I want to put a colon and a space so that when this runs, see how it looks now? Please enter 1, 2, 3, or 4, and it's waiting on me right there. So an 8 shouldn't be there either. Okay, so we've kind of tested this out, and we know that everything is working up to this point right here. So we can keep writing the rest of our program, which is not very much left actually. So otherwise, position contains the location of the option chosen in the array. Okay, so we can use that to get to everything else then. Cable gauge, that's this variable right here, string cable gauge. We're going to use that position to get the right gauge from this array right here into that. So cable gauge equals gauges. Did I spell gauges I spelled it wrong. There we go. That's better. Okay, gauges, square bracket, position, square bracket. So at that point, we will know, our program will know which one was chosen using the position that we got right here from our linear search. So next we can get our cost per foot. And what was the name of that called? Cost underscore foot. What did we call our variable? Cable cost, sorry. Square bracket. Okay. So at that point, we've got everything we need. We're ready to just print things out now. Okay, so here's going to be our C out. Set precision. Set precision 2, and we'll fix our decimal. Okay, and now that is our wire size is going to be in cable gauge right there, so we can do cable gauge. At a cost of, our price is in cable cost. Let's put a $sign right here. Cable cost. And L. Okay, so we've got that. We can run this again just to make sure everything is working. Looks like I messed something up here. Set precision precision. Okay, compilation finished successfully. Let's run it. So it should be looking up our cable gauge and our cost per foot now. So why don't we try a 3? You can see a 3 should come back with 10 gauge at 51 cents a foot. Okay, that's 10 gauge at a cost of 51 cents a foot. So we're good. You notice how I'm building this a little bit as I go, right? So now let's prompt for the number of feet. Okay, so C out. How many feet? Let's see, we want question mark there. CN. Feet ordered is, I think, what we used. Let's see. Yep, feet ordered. Okay, so we've captured that. Now we can do our last little bit, our math, and we're done. Calculate the total cost. So that should be total cost equals cable cost times feet ordered. Okay, and at that point we need to print it out. So gonna copy this line and paste it. We're still gonna print it out with 2 decimal places and fixed. So Cout feet ordered feet of cable gauge will cost, put our $ right there, total cost. Okay, save this, build it, no errors, and run it. Okay, let's do 3 again for 10 gauge. 10 gauge wire. Should be 51 cents a foot. It is. How many feet? 100. 100 feet of 10 gauge will cost us $51. So that's the end of that little example. You can see as a review, I used the algorithms linear search. So I had to include algorithms here. Here's my function template. This part is vital right here, and especially passing the array by reference if you want to use the linear search function from the algorithms library. Now, also remember that if you're using characters for your menu options A, B, C, or D, then this might be a char and this might be a char. And of course, if you're doing that, your linear search would need to have a char right here and a char right there. So that's the end of this example to process a menu with 3 synchronized arrays and using a linear search from the algorithms library. Good luck.